Hello everyone, welcome back. Hope you guys are doing good. Myself Rahul. So today we are going to solve a problem related to arrays and recursion. So the problem name is combination sum. So let's go through the problem. It's a very easy problem. Here we are given an array of distinct integers candidates and a target integer target. We have to return a list of all unique combinations of candidates where the chosen numbers sum to target. You may return the combination in any order. Right, the same number may be chosen from candidates an unlimited number of times. Two combinations are unique if the frequency of at least one of the chosen numbers is different. Okay, it is guaranteed that the number of unique combinations that sum up to the target is less than 150 combinations for the given input. All right, so just to brief, so like we are given an input array here, in this case 2 3 6 7, and a target sum, when in this case it is 7. So we have to basically return which all subsets of the given input vector sum up to the given target. So in the end, one more thing is we can take a particular number any number of times, unlimited number of times. So here this is the input vector, and obviously these integers would be unique. So in this vector, to make a value target as 7, we can consider element 2 any number of times which we want. Similarly with the case of 3, like we can use 3 any number of times. So if we suppose use 2 number of times and 3 just single time, so the subset would be 2 to 3, which would sum up to 7. Similarly, if we just consider LU as 7, so here as well the target is 7. So these are the two possible answers which we need to return. Other cases 2, 3, 5, we need to make the sum as 8. So in this case, if we consider all the elements as 2 and use 2 4 number of times, right? So this is one of the possible answers, and we can use 3 2 times and take 2 as well. So 2 plus 3 is also 8, and 3 plus 5 is also 8. So we need to return all those possible subsets. I shouldn't call them subsets, basically all those arrays which sum up to a given target, and we can use a particular element any number of times. So it's a simple case of recursion. So let's see like how the recursion would come into effect in this problem. So let me take an example. So let's see, I will create one example called like the input vector is 3 4 5, and let's see like the sum we have to create is 8, right? So initially we would be starting with an empty vector which we need to return. So we are basically creating this particular set at a time, right? So we will be populating the elements inside this particular vector. So what we will do is we will initialize this vector with an input value, empty value. So at this particular time I have two possibilities with me. Basically like I can consider this 3 to be a part of the subset. So in this case it would be just 3 over here, and suppose I don't consider 3 to be a part of the subset or the answer. So in this case, let's suppose I consider 4 to be a part of the answer, like I am starting with basically 4. And the third case can be I completely ignore 3 and 4, I start with just 5, right? So suppose coming to this part of the tree, left hand part of the tree, I have this particular value 3 in the input vector v, right? So at this point I have couple of possibilities with me, like as mentioned in the question that I can consider an element any number of times. So suppose I consider 3 value again, right? So the input vector or the vector v would have value 3 and 3. Suppose at this point I don't consider 3 as the next value, so here I suppose consider 4. And even if I don't consider 4, let's suppose the value I consider over here is 5, so it would be 3 comma 5, right? And I will keep on checking like what is the sum till now. So here the sum is 6, here the sum is 7, and here the sum is 8. So as I have encountered 8, I don't need to go further down in this recursion tree, right? So I will return this as one part of the answer. So this 6 is still less than 8, so I can further go down one level. So I am currently at this index only because I've just used 3, so like I can still append 3 to it. Here the sum would become 9, so 9 is greater than 8, which means this cannot be a part of the answer. So I don't need to go further down in the recursion tree. Now coming back to this 3, instead of appending 3 here, I can append 4. But here as well the sum would be greater than 8, so I will completely ignore this solution. The other part of the solution can be 3, 3, 5. Here as well, the sum is greater than 8, so I can remove this solution. Right, so coming back to this part of the tree 3 comma 4, here I have some possibilities with me, like because the sum was 7 which was less than 8, so I can still go down in the tree. Right, so I can append 4 over here because I am already present at the 4, this index 4, so I can't go back. Right, so I can't append 3 over here. Right, so that would be an invalid scenario. So if I append 4, the sum is greater than 8, so it cannot be a part of the answer. Similarly, if I append 3 comma 4 comma 5 5 to it, this is also greater than 8, so this also cannot be a part of the answer. Now coming to this 4, now suppose at this 4 I append 4 again. Right, so here the sum is 8, which means it is definitely an answer, so I am going to return it. Now coming to this 5, it cannot be a part of the answer, so because here the sum is just 5, so can I append 5 comma 5 here, because the sum would come out to be 10, but it won't be, it is greater than 8, so it cannot be a part of the answer. Right, so what are the possible answers we have encountered till now? So these are the recursions. So basically we will be doing an in-order traversal in this tree. So I will be going first to the left hand part of the tree. I will be creating this 333. It is not an answer. So I will go to the right hand part of the tree. This is also not an answer. Then I will, this part of the tree has been covered. Right, so I will go to the right hand part of this tree. So this 3 comma 4 is a part of the answer. So I will append to my answer vector, which I have to return in the function. I will append this particular vector into my answer vector. Similarly, like after this part of the tree has been completely covered, I will go to this 4 node and I will find that 4 comma 4 is also a possible answer, so I will append this 4 comma 4 vector into my answer vector. Right, so here the two possible answers are 3 comma 5 and 4 comma 4. Right, so I have already written the code for this particular problem. Just a second. Yeah, so this is the function that we had to finally write. So in this combination sum we are given an input vector and a target which we have to compute, which you have to create. Right, so I've created one vector of int v, which is basically keeping the track of the elements that I have currently encountered into my recursion tree. Right, so this is the vector I've created, and I've created one function in which I am passing some arguments. So let's try to understand what those arguments are. So first is, one is the input vector, obviously, one is the target value, and one is the current sum which I have made till this particular point of time. So when I'm iterating over this or going through this recursion tree, right, so I have to somehow maintain what is the sum of the particular point vector in this recursion tree. So like suppose I am at this particular stage, I need to somehow maintain 5 plus 3 equal to 8 so that I can match this current sum with the target value I am computing. So if the target value is equal to the current sum, which means I have reached my solution, like this is also a part of the solution, so I need to stop at that particular moment. So that's why I have passed this current sum, which is initialized to 0, and the vector v, and one index variable which is called as j over here. So why this is needed? Because if I am going to the left hand part of the tree, uh, so suppose if I am going to the left hand part of the tree, so these are the index values 0, 1 and 2. So this j value would be initialized to 0. if I am starting with this 3, if I am at the this part of the tree, middle part of the tree, so here the j value would be 1, which means if j value is equal to 1, I cannot take any element of the index less than j. So if j is equal to k, suppose, right, so if the input vector was very big, was 1 2 3 4 5, something like that, and j value was somewhere around here, which means in the further recursion calls I won't be considering any element before j, right, because those would already have been covered when I had created the tree for them, right. So in this case, as we can see, when I had reached j is equal to 1, I won't be considering any value 3 over here. So in this part of the tree 4, I haven't appended 3 to this particular 4, right. I can only append 4 to it or 5 to it, because these are elements present at that particular index or after those. So that's why I am passing this variable j over here, and at every recursion call I am just checking the current sum in my recursion call, is it equal to the target value. If it is, then I am just appending whatever value is present in my vector or the complete vector into my answer vector. So it is very similar to what I had explained in the previous problem as well. In the subsets problem, I had solved it using a similar fashion in which I was just appending the vector v into my answer vector, right. So if the current sum is equal to the target, I have to return from that particular moment. Also, one more thing I have to take care is, like, if the current sum is greater than target, I just need to return it. I don't need to consider the further recursion calls, right. And this is because if I have the current sum is greater than the target, because then even if I append other integers to my current vector v, the sum would obviously be greater than the current sum, right. So suppose the current sum value is 9, and the vector v is something like 2 7, something like this, right, and the target value is suppose 8, right. So current value is 9, target value is suppose 8, which I have to make, and the vector v is like this, and the and all the elements in this problem in the input vector would be positive. It has been mentioned in the question, right. So the candidates of I is ranging from 1 to 200. So if I append any positive integer to this vector, suppose 3 to it, then only the current sum value will only going to be greater than the target, right. So it won't be of any help to me. So I'm basically returning from here itself so that I don't have to do unnecessary computations. And this is the for loop I have written. Basically, I am starting from the jth index. So initially it would be 0, and so one of the cases can be like I just consider the current element which I am at. So I just push back whatever value I have at the ith index into the vector v, and again call recursively with my current sum updated as current sum plus array of I. Right. The other possibility can be I don't take the current element present at the index I. So in that case, I need to take the next element. So in that case, like whatever value I have pushed back into the array or the vector, I need to pop that element first so that the next value can be pushed. So if I explain it using the example, so in the tree that I had created, right? So initially the tree was like this, 3 3, it is like 3 3 over here, correct. So I need to basically pop the element out of it. So one of the things can be I just append 3 3 over here. So I need to go, if I need to go back to the recursion to backtrack, so I need to pop this element out of it, right. So that's what I am doing over here, v dot pop back, so that other values can be considered. So I had appended 3 to the existing 3 over here. So suppose I don't want to append 3 over here, I want to append 4. So before that I need to remove this particular 3. So that's what has been done over here. I just remove what I had pushed into the stack, the last element, and coming to the for loop again, I will push the next element present in the next index. Right, I hope the solution is clear. Let me try running this code. It's already tested, but yeah, let me submit it. Yeah, runtime and memory usage are fine. So like it's a very I would say very important problem related to recursion because it clears up a lot of concepts. So I would definitely recommend you to go through this problem and try to build this recursion tree and see like what are the possible scenarios we are going to encounter in the tree. Right, and yeah, I hope you understood the solution. And if you have any doubts or clarifications, please do comment in the comment section. And I will see you next time with another problem. Thank you.